I was challenged to come up with a presentation, but I think eventually I decided on only 3 topics because it's a 20-minute presentation or keynote address. And I'm trying to set the scene hopefully for the next 2 days. So I'm only going to deal with 3 topics which I think are very relevant and topical today. Also just wanted to correct one thing. I was a director at Xstrata Alloys, and I've just completed my 1-year contract with Eskom as an executive advisor. So, so at least I'm free to speak. Not that I wasn't before. Okay, so I've been asked to talk about, as a keynote address, understanding mining's energy challenges and the potential solutions. The picture, by the way, you see there's a company I work towards, Richards Bay Minerals, who mine the titanium sands in the northern KwaZulu-Natal coast. And those dunes have all been mined out and rehabilitated. And I think that company can be rightfully proud for their rehabilitation efforts. So the 3 topics I want to talk about, and I'll close off with a suggestion on a solution and a role for mining, and obviously for the renewal fraternity as well. A big issue is, what do we envisage is going to be the growth? And in this case, I'm specifically referring to electricity, which for many years has been directly tied to GDP growth in South Africa. That equation is changing. So the question is, how much growth can we expect, and how is that growth going to come about? 2 questions which are extremely important for mining. I am pressing the button. There's growth. I took this out of a newspaper, and I think we all understand that in South Africa in particular, jobs is a crucial issue. And you'll see this article said it's a ticking time bomb. So really the issue is around, from a social perspective, the jobs that we are going to create or sustain in this country. And it's quite topical that this article, which I took a while back, talks about an event that we've all recently heard a lot about in the news, which is Marikana. So, what I've done here is I've taken the GDP percentage growth in South Africa from 1947 through to 1935. The 2 black lines, I've just connected the upper and the lower of the graph. And the first thing that you notice is that the GDP growth has progressively declined. If you took a line in the middle of those 2 black lines, from around about 4%, and progressively and steadily is declining. But for me, the most significant thing is those colored lines, which are all government planning lines for growth. Now, clearly everybody can see from that it's not possible, and nowhere in our history have we seen growth that returns that rapidly and to such high levels in such a short period of time. And I wish to show you why. I've drawn the blue line, which is the latest forecast for growth. And again, I think these are optimistic projections. This has had a profound impact. One of the things that I was asked to help the Department of Energy with was to project manage RP 2010 and the RP update, RP 2013, which we know has not been published. And this issue of growth is at the heart of coming up with a sensible growth plan for electricity in South Africa. I got this from a McKinsey report, and it struck me that if you look at the past 50 years, that's the 2 top blocks, the growth from productivity growth and labor growth was about the same. Productivity 1.8% annually, and labor growth 1.7%. They predict for the next 5 years, productivity growth will be about the same. But here's the kicker. The growth from labor will decline by about 40%, giving us only about a 0.3% growth in labor growth. In other words, that's physical growth in terms of labor created in industry and in mining. And I guess most of the mining companies I know well, which are very labor intensive, are all looking at ways to reduce their labor costs. If you look at the platinum industry, it has to find a solution to the high cost of labor. It just cannot sustain that model. And all of them are looking at ways to do that. So this issue of productivity growth goes way beyond just the output per unit of labor, but it goes to things like automation. It goes through issues like much more efficient processes, and in particular, the much more efficient use of energy. From the same study, they just show something which I think intuitively we all understand. All those dotted lines, the countries are shown on the right-hand side there, clearly show massive growth in employment in the manufacturing sector. And as soon as, if you look at the horizontal axis, which is the wealth of the country in GDP per capita, improves, so there's a decline in jobs in the manufacturing sector. This is already taking place in the mining and in the industry space in South Africa, and in particular fueled by the high energy costs. I was fortunate to be in Korea on a government invited study tour on carbon, which is something which is quite important for the renewable sector and mining. The blue dots is South Africa and the red dots is South Korea. And you will see in the beginning, which is, I can't see from here, but I guess that's probably in the, is it 60s down there, the beginning? South Africa's wealth was about double that of Korea. In the 70s, it crossed over and we were about the same. Today, they're 4 times more wealthier than we are. They have no natural resources at all. That doesn't mean that natural resources need to be a curse. It basically means we need to think about natural resources in a more productive way of use and extraction and beneficiation. And obviously a better use of human resources. I then took this from the World Economic Council study on competitiveness, and on the vertical axis there that's pay, labor, productivity, and our horizontal axis is the quality of maths. And I've put countries that are relevant to us. I've also put South Korea just by way of an example. And you can see this is an issue which the country is disappointing itself in. Our labor productivity is way lower than many of our competitors north of us, just north of Africa. And in terms of maths and science, we've got a way to go. This has to be addressed in terms of serving the needs of industry, and in particular mining and the country. So the next one, which I think you're all interested in, is the price of electricity. What this graph shows on the vertical axis is energy intensity, and on the horizontal axis is the US dollars cents per kilowatt hour for electricity in 2000, I think it was 2013 terms. I beg your pardon, those were all nominal. So what it shows, there is a natural curve that as your intensity increases, so your electricity prices drop. It's virtually in line. The outliers there are Kazakhstan, Russia, and China. But the red dotted lines, or dots that I'm showing, eventually a solid dot, shows the trajectory where South Africa's electricity price is going. It clearly is an outlier, and for an energy-intensive industry such as South Africa, which is not going to change, this is not sustainable. We have to find solutions to ensure that as South Africa progresses down the intensity curve, in other words, it's a transitioning economy, we have to make sure that as prices increase, they at least increase in line with the countries that we will be competing against. So the first danger sign here is that we are very reliant on the energy-intensive sector, in particular mining and industry, notwithstanding the smaller role that it plays. But you must remember the secondary and tertiary sectors that feed off the mining industry is massive in this country. So we are reliant on mining and industry. We can't get away from that. But we cannot afford to become an outlier and price ourselves out the market, both in terms of energy prices as well as productivity. I'm not going to delve on this, but it is quite an important slide. The horizontal axis is cents per kilowatt hour in South African rands, and the vertical axis is the accumulative sales in electricity. I want you just to look at the size of the arrows, the orange ones and the blue ones. And I'm comparing America, the United States, to South Africa. The first thing that will strike you is that the mining industrial consumption is significantly more, 70% of total consumption. Whereas in America, it's roughly around 20%. You may ask why this is significant. It's significant because the mining and industrial sectors normally need to get electricity at wholesale prices to survive. And if they don't, they'll fall forward like that red line. And the minute that red line touches or goes beyond the blue, it means that nearly on every sector, South Africa will be as expensive as the United States. And the consequences for us will be significant. So we have to find a way to keep ourselves to the left of the blue in South Africa. And if we see where the electricity prices are going at the moment, this is not helpful. However, if you look then over the long term, the blue line is where, this is all in real terms. I haven't updated, this is 2013 real electricity prices. And the blue line is where South Africa electricity prices have been. And you'll see where they are somewhere midway in the MYPD3 application. We're now sitting midway in the cone of electricity prices for industrial and related industries in China and India. So we're now not at the bottom quartile of prices, we're now in the mid. The cone indicates where the prices could go if it's not managed, and I indicated with a red dotted line there where I think the price should go, and I'm going to show you in a second why. But this is very important for a symbiotic relationship between renewables and mining, because renewables do need that price to provide them a return for investment in their generation, but at the same time the price needs to balance that with affordability. I then yesterday took two scenarios. The scenario with the cross is in fact what Eskom has applied for. So you'll see the blue bars is the percentage price increases which I've forecast would have been made had that been allocated. But the green line shows where the price rises, and you'll see it rises there, I think, to about 90, is it 90 or 95 cents? I think it's 95 cents. I don't think that price will be kind to mining. It will create a serious problem. I then showed what I think could be an affordable price, and I'm showing there's something above 80 to 85 cents. Now this is quite important because these prices need to be known. It is nurses' obligation by law to publish a price path like this. They have not done so. I also believe Eskom has a responsibility to publish such a price path to show where the price path goes. It's unacceptable that we are confronted year in, year out with these massive swings in price increases. Every investor, whether he be a miner, an industrialist, or in fact an investor in power generation, needs to know what this price path is. So and this price path can be calculated. I calculated this one. So the big question on your minds is the shortfall in supply. I'm also going to say there's a question about a surplus of supply. This graph very quickly is the capacity outlook from 2015 to 16. So how it works is the vertical axis is in megawatts. And the first thing I want to draw your attention to is the top of the purple or the orange colored area. The top of the purple colored area is the anticipated and actual current total installed capacity. Not available, total installed capacity. Those little blue colored indicators show where the current forecast is for new generations, such as Medupi Unit 1, then the pump storage units and some peaker plants. And you'll see that's why the orange area rises, because we are adding new capacity. Not a lot, but some. The width of the orange is the amount of breakdowns. That's the amount of plant that is not available or lost, the capacity that is lost due to breakdowns. And you'll see it's quite significant. Then the green area is the capacity that's not available to allow for units to be removed from service for planned maintenance. The white area is the capacity that the OCGTs, or these gas turbines, add, which leaves you with a blue. So under normal circumstances, the blue is what is available on a daily basis. Now here's the kicker. The black line is the capacity that is required without load shedding. So what it shows that for the rest of this year, if anybody says there will be no load shedding, they haven't looked at this graph. This graph shows that there's a gap between the black line and the blue area in terms of available capacity. To bridge that gap, you add the OCGTs. And if you look very carefully for this year, even if you add them, we are still short of the black line. So the graph also shows some promising signs. It shows that in the beginning of starting next year through to the end, the blue line progressively gets closer and closer to the black. And the reason for that is because you've got to look at the two lines below the black, which is the blue and the red. That comes from two areas. Additional other capacity added. I need to add one comment I didn't make, I beg your pardon. All renewables are not counted in the installed capacity. They reduce the height of the black line. In other words, renewables reduce the capacity required. They virtually feature in the demand equation. So the reason the black line is closer to the blue is we're adding more capacity from non-Eskom generation, and the red line indicates demand-side initiatives, such as demand-side aggregation. So the first thing you can see there is that we have to get these non-Eskom supply-side options and demand-side options in place. We are duty-bound to do that. We cannot go through another year like this year, where the black line is that far from the blue. This came straight out of the RP 2013 update which we did. And what struck us at the time is that the solid lines were the forecast using normal forecasting methodologies for electricity demand in terawatt hours. So the vertical axis is terawatt hours, the horizontal axis is the years. And the three solid lines were uppercase and lowercase scenarios. The dotted lines was a CSIR scenario, and you'll see they projected upper and lowercase scenarios lower than the standard model. And the little red line is where we're actually going. So currently, our electricity demand consistently is even lower than the CSIR's lowest forecasts. This is of concern to me because this indicates economic activity. And the question you can ask yourself, why is that line there? And there can be only four possible reasons. The first one is a restriction in capacity, which holds back new demand coming on stream. 2, the impact of price on demand. 3, the global economic situation, which is not as good as it should be. And lastly, the labor situation in South Africa. I think those 4 areas are playing heavily into this. Obviously, added to that is certain policy and policy uncertainty issues. But the point of this is we need to find a landing on what we're going to plan for in terms of growth. Because if we don't, we could sit with surplus capacity. The other alarming thing is that the mix from the demand side sectors are changing. So the left-hand bars is in energy and the right-hand bars is in demand. The tall bars is the 3 years total energy and maximum demand from the combination of mining and industry. And you'll see over those 3 years, they progressively have declined, both in energy terms and in maximum demand. Another thing about this is the subsidy of electricity between customers flows from mining industry to the other sectors on the left. If there's a contraction in those sections in demand, so does the subsidy contract. And if those prices for those lower-end consumers have to be sustained, it means the right-hand, the big consumers have to pay more, as they have been doing over the number of years. An unsustainable model. So apart from the contraction in energy, it's starting to have an impact in the mix of prices charged for the energy sectors. The only sector that grew there, if you look on the right-hand side, is quite significantly is residential. And the residential demand only grows over that short period in the peak, for which those OCGTs have to serve, and that's very expensive. So, in conclusion, what is the role for mining? I drew here what I call the policy cube of South Africa. So there's 3 key dimensions. There's time, in other words, short, medium, and long-term plans. We all know that we have, at the moment, no long-term plan for South Africa as a country. What we have is a medium-term plan, which is the NDP, the national plan, but that only goes to 2030. What we need is a longer-term plan. The vertical axis are the key policy areas that drive us towards our objectives, which are the three on the right, and I suggest the three objectives for South Africa has to be economic growth, which is transformational, political transformation, which is sustainable and predictable, and social transformation. Of those three objectives, I would suggest to you that social transformation has made progress. I would leave to you to ask yourself whether on economic and political transformation we've made sufficient progress. My concern is that as mining and industry, and also as an industry, and I include here the renewable fraternity, we need to be much more proactive in expressing views around what can and can't work in the policy space. I think we are too silent. I think we are too hesitant to participate in that space, feeling that we will be attacked as critical. We don't have to be critical, we have to be constructive, but we can provide facts and information which government do not have. And so this is the model. You'll see there are four quadrants. On the left-hand side, quadrants, that's the role of government, and on the right hand is the role of mining industry, if you will. At the moment, we've got too much policy making. In fact, we make policies to fix policies that don't work and end up making policies to fix those as well. That's actually what's happening in the country at the moment. It's unsustainable. It just doesn't make sense. When it comes to implementation and getting the facts straight, there's way too little taking place in that space, and it's an area that government naturally do not have all the resources. At the same time, mining and industry, I believe, are playing too much into the lobbying space, and they are perceived as party poopers who don't want to participate in the policy space. The time has come where mining has to step up and get involved and provide meaningful information and honest comment, and that's what I call fact-finding technical issues. Advocacy, I would call it. There's too little of that. So in conclusion, I think we should work together and start making it clear to government that we wish to work together, to simplify things, to collaborate, to have less regulation, but to have better implementation. Thank you.